This video will focus on the target. I can properly classify substances according to their properties, given words like element, compound, heterogeneous mixture, homogeneous mixture, pure substance. Okay, there's etc. there, but I think that's pretty extensive. So the first few words to think about how matter is organized are the words element and compound. Okay, elements are those things on the periodic table. They have a consistent composition if you were going to look at them, and more than just having a consistent composition, they're unable to be broken down chemically. Okay, what that means is if you had a sample of pure iron, when you looked at it, you would see no impurities. It'd be uniform in composition. It would all be one color. But then if you tried to chemically interact with it, you would not be able to take it and break it down into smaller components. Iron is iron. There's nothing else to it. Okay, comparing that to compound or molecule, a compound or molecule is something that consists of elements, but those elements are chemically combined with one another. Okay, so it still has constant composition. So for example, in your head, if you had a picture of like table salt, if you looked at pure table salt, is completely uniform in composition. It has no variation in color or texture. All of it looks very uniform. But if you were to start to interact with it chemically, you could actually break it down into its component elements, which are sodium and chlorine. Okay? So a compound will be always two or potentially more. There are things with more. Baking soda, for example, is sodium bicarbonate. It has sodium, it has carbon, and it has oxygen all bonded to one another. So if you're going to start to interact with that, you can get sodium out, carbon out, and oxygen. But the big thing about a compound is that all of those things are chemically combined with one another. So they have what we call bonds. The only way to break them is to chemically break them. They've been chemically combined. Both elements and compounds are something that we call pure substances. They look uniform in composition, and they are uniform in composition chemically, meaning no matter where you look at the matter, it will always be chemically the same. Right? Pure sample of iron, everywhere you'll have little Fe atoms. Pure sample of sodium chloride, everywhere you look, you'll have little NaCl clumps. Okay? They're very uniform, but they're considered what we call pure. The opposite to a pure substance is a mixture. Okay? And the difference between pure substances and a mixture is they're no longer chemically uniform. Okay? So a mixture is similar to a compound in that it now has two or more elements combined to them, or two or more things, but rather than being chemically bonded to each other, they're just physically mixed. Okay, so the example of this would be like Kool-Aid. Kool-Aid has that red sugar compound, red sugar substance, I guess, and water, and you mix the two together, and you still have the property of the water, and you still have the property of the Kool-Aid. They're just now in one location, right? Salt water. You put the salt in the water, the salt is still salty, the water is still water, they're just together. So mixtures are not considered pure substances because they have two things that are mixed, but they're not bonded. So if you were to take a little up-close snapshot at any location within the mixture, you would not find uniform chemical composition. Okay? Just to compare this to compounds again, one example I love to give is that sodium chloride. If you were to take sodium chloride and break it up into its component pieces, unbond sodium and chlorine, you would get sodium, which is a metallic, shiny silver metal, and chlorine, which is a green toxic gas. Right? So shiny silver metal combined with a green toxic gas gives you a white crystal. That's a chemical bond. For salt water, if you put that white crystal into your water, the white crystal seems to disappear, but its chemical makeup is still there. You still taste the saltiness of salt. So it didn't chemically change to something new. When it comes to mixtures, we have two different types of mixtures. We have a homogeneous mixture or a heterogeneous mixture. So homogeneous mixtures are totally uniform in terms of how they've mixed together. Usually for a homogeneous mixture, you can't tell you can't distinguish one of the substances from the other within the mixture. So again, like that salt water, that Kool-Aid, you don't see the powder anymore, you don't see the salt. Right? It's very uniform in composition. Heterogeneous mixture, on the other hand, looks lumpy. So if you picture like a mixture of sand, sand has very many different sized rocks, different colored rocks, and it's not uniform in terms of its appearance any way, shape, or form. So a homogeneous mixture will have things physically mixed together, but they'll look very uniform, where heterogeneous will be physically mixed together, but it'll look very non-uniform in terms of its composition. A couple words we use in relation to mixtures are alloy and solutions. Both of these terms refer to homogeneous solutions, so they're uniform in composition. An alloy is actually a homogeneous solution of metals. So when you get like sterling silver or bronze or brass, those are all mixtures of more than one metal, but they've actually been melted and mixed with one another to make a solution, what's called an alloy. A solution is just a homogeneous mixture of two things. The word dissolving usually goes with solutions. Kool-Aid and salt water are both examples of solutions, as is air. Air is considered a sample that is a solution. So those are all your different classification terms. Have a nice night.